Today is May 29th, 2022. It is a Sunday. It is also day 315 of data science, and today I'm going to be calculating binomial probability using Python. So I'm going to first write the code and then I'll explain. And then we can read the problem and explain everything. So from SciPy, import stats.binom.pmf, and then k and p, and then I'll define the variables k, n, and p, and then k would be x, the number of left-handed students in the sample, so the number of successes that we're looking for, so that's 2. N is the number of trials, so how many students? 4 students. And the probability of a success, which is small college, is 10% of which are left-handed, so 0.10. Okay, and then run that and round it to 2 decimal places. Okay. Alright, and then let me check if it's the answer here. Or was it 0.05? Okay, so yeah, so just to show you that it's correct, now I'm going to go and explain to you what basically I did. So let's read the problem. A small college has 800 students, 10% of which are left-handed. Suppose they take a simple random sample of 4 students. Let x equal to the number of left-handed students in that sample. So what is the probability that exactly 2 out of the 4 students are left-handed? So this is a binomial problem because we have 2 possible outcomes for each event. So so basically binomial, I can't even spell. Binomial, you can think of it as bi, right, which means 2, so 2 outcomes. So for each event, there's 2 outcomes, and one outcome is a success, and one is a failure. So those are your 2 possible outcomes. Either you have a success or a failure. In this case, each event, let's say, is a student. This is also known as a trial. So each event is a student, and for each student, they could either be left-handed, or they could be right-handed. Now, how do you know when which one is a success and which one is a failure? Usually, they only give you the probability of a success within one event. And so because they give us the probability of those who are left-handed, then that tells us that left-handed is a success that we're looking for. It's also probably it's whatever they're asking you here, like the probability of a certain number of students out of a certain number of students be left-handed, if that makes sense. It's usually in the question. So each student, you have an outcome, left-handed or right-handed. And so basically they give us the probability that they're going to be left-handed, and what we have to do is we have to calculate that probability that exactly 2 out of those 4 students are left-handed, because they're taking out of 800, let me draw a picture. You have 800 college students. I'll do this. So you have 800 college students, and let's say you take a random sample of 4 students, right? And so that's your sample size, n, right? And so these are 4 students now. And from that sample, they basically want to know, out of those 4 students, what is the probability, right, that x is equal to 2, x being the number of students who are left-handed. So it's basically the number of successes that we're looking for. So number of students who are left-handed, or we can think of it as a number, generally the number of successes we're looking for, because again the success is being left-handed. I can't even spell. Anyway, whatever. But here's the thing, in Python, it's a little different. I'm not gonna go over how to do this with the calculator. That would probably be in another video. But in Python, x, we don't have x, we have k. That's literally the only difference. I mean, besides the order of how we put the parameters inside, but whatever. X is literally the same thing as k in Python, okay? Just know that. It's the same thing. It's just another variable. It's just another letter. It's the same thing. So instead of x, I'm just going to be saying probability that k is equal to 2. Or k is going to be the number of successes that we're looking for. Or the number of left-handed people that we're looking for. Okay, so just to give you context of what we're doing, so if we go back to the code, you'll see here, the first thing I did was imported a function from a library. Now, a library in Python is basically a place where you have pre-written functions for you. So functions are something that you can call, and they do fancy calculations, and they return an output. And so I'm going to use the SciPy library, which has pre-written functions, and one of them is the stats function. And from stats, you can use methods. So I'll call the function stats and then do binom.pmf. Now, there are different binom dots. There's binom.cdf, which we can get into later. But PMF stands for probability mass function, and it is the equivalent to PDF in your stat class. So in your stat class, you might hear PDF, but over here in Python, it's PMF. And what that does, it finds a probability at exactly a certain point you ask for. So in other words, let me rephrase that. It finds a probability of an exact number of successes. So an exact number of x or k. So in this case, it doesn't. Well, yeah. Let me just end there. It just finds when you have an equal sign, you use PMF. Okay. If you have like greater than or less than or greater than or equal to or less than or equal to, you use CDF. That's the sum of it. But PMF, and then we have 3 parameters, so K and P. Now, the way I remember this is usually when you're texting someone and they and you do them a favor or you say something, whatever, and then you're like, they say thank you, and then you're like K or like no problem. But I just remember it as like, okay, no problem, like K, no problem, whatever. So K and P, that's how I remember it in Python. Again, in your stat class, the order that you put it in is actually different. So K and P, if it makes your life easier, you can think of it as X and P, but it's K in Python. And then I just rounded the answer that they gave me by 2 decimal places by using the round function. So round, and then 2 decimal places. So round takes in what you want to round, and then how many decimal places you want to round it to. And since it's the 100th place that we have to round, I did 2 decimal places. Okay, so K, again, just some notation. K is your X, in this case. It's the number of successes you're looking for. In this case, it's the number of left-handed students that we're looking for. That's not how you spell looking. And then N is the number of trials or events. In this case, let me see, number of trials or events. In this case, it's the number of students that we have, number of students. And then in our sample, right? And then our probability, our P, is the probability of a success of a success for each event. In this case, it's the probability of one student being left-handed. So for each student, there's a 10% probability of being left-handed. Did I spell that right? Probability of a success? I never know how to spell this word. Like, okay, whatever. Alright, and that's basically what we did. And so you basically round it to 2 decimal places and you get 0.05. And that's the probability that exactly 2 of the 4 students are left-handed. Okay. Let's see. Yep, that's pretty much it. Yep. Okay, bye.